Hey all, and welcome to the SystemVerilog for verification short videos. Today we'll have a look at the concepts of class and OOPS, that is object-oriented programming. It's been seen that hardware engineers are not really sound with the concept of OOPS because they mostly work with hardware declaration languages like Verilog, VHDL, and these languages really don't care about OOPS. But when it comes to SystemVerilog, when it comes to verification, OOPS are widely adopted here. So it's time to learn OOPS. Agenda of the today's class is to go through the class basics, class format, class object, constructor. It's different with the structure, static property, and static method. From next tutorial onwards, we'll have a look at key concepts of the OOPS. They are polymorphism, inheritance, etc. So let's start with the first topic, class basics. Class is nothing but a data type. We have gone through multiple data types like int, logic, bit, struct. So class is just another one. This includes two members, data and subroutine. Subroutine in other words like function and task. But when it comes to class terminology, data are called class properties and the subroutines are called class methods. Class properties are nothing but the variables like say int I, then logic x, and class method. So we'll write some function inside classes which will operate onto the class property. We'll have the example look at this after we go through the format of the same. So let's go through the class formats. It's like write a keyword class, then your class name, and it ends with end class colon, then again your class name. And inside, first we declare class properties. Then we define class constructor function, which is also used to initialize class property. And lastly, we define some function and task. So in GVM, let's have a look at a sample class code. I'll say class home, and I'll end it with end class, and I can write here colon home. Here now, first task is to declare the class properties. So I'm declaring say bit light, then I'm taking int fan. As you can see, I'm using different class properties, bit int. I may use logic, say door. I can also go with some constant here, say const integer window. I want its constant value 1. So here, my first task is clear, that declare class properties. So I can declare as much as class property variables here. Next task is define class constructor. So it's basically a class constructor function new. We'll talk about this later, but right now we'll just have a look at this function, same as this is just another function. In this, I can also use initialize the property. So I can use here initialize property, say my light equals 0. So these are some default value I give him. Then fan equal to 0, as both are bit and int. I can put door equal to x. Yeah, that's it, because this is constant integer and it's already having value 1. So my second task is over, that is class constructor function. And the last task is to define some subroutines. So let's go for that. Say I am saying some task open electricity. It sounds good that in class home I am having some open electricity subroutine. And task in that say I'm saying put light equal to 1 as it's open electricity, and also fan equal to 1. You see, here I have declared one subroutine that is operating onto my class property. So I can say this is a class method that is operating onto this class property. Let's take one another function for clearance. Say function logic door status. It will provide me the status of door and function. Inside that, say door status equal to door. So because my function name and variable name are same, it will return this store status. It's type logic return type. Okay. So here I'm having one class format. I'm having property, constructor, and some class methods which are operating onto my class property. Okay, now let's go on to the next topic, that is class object. Okay, here class defines data type, but object is the instance of that class, because class is just a data type like struct, and not even struct. When we use struct with type def, then type def struct is somewhat similar to the class, so then we need its object. Okay. That two steps to make class objects. Step one, declare object. Like what I've done here is home space h. So here home was my class type and h is object. So I've declared an object h of class type home. And next step to work with the object is to create object, which means h equal to new. I need to call the constructor function of the class like this, h equal to new. So now it's created. One more thing to discuss here is if step 2 is ignored, then my object h will be having null value. So a good method to write for creating object is I will write if h equal to null. So if h is not yet created, let's do h equal to new. I can go for that, right? And how to access the class property and method. So I will use dot for that. So what I've done here is my class property in my example was say light fan. So what I've done here, I have used light using h with dot operator. So h dot light equal to 1. And if I want to call the open electricity task, then what I will do, I will do h dot open electricity. So I can use dot to access class property and method. Here is some fun, that how I'm calling the any function. I'm doing it with h dot that function, right? H dot method. Now we say this is object oriented programming. Another one, say C, that is function based programming, and this is object based. So what's the function? How can we know the function, the difference between two? So first one, which is function based, I would have said my status equal to door status, and I will pass as argument object h. So here my focus is on function, that I'm calling a function and I'm passing the object as its parameter. And then I have here something that is written from the function. But because I'm working with object oriented programming, my main focus is not a function, rather my main focus is edge. So I have done edge dot door status, and the return value will be stored into status. So I'm not giving priority to function, I'm giving priority to object. So here you can feel the difference between two, function based and object based programming. Class and oops, they are dynamic. Here is a big catch, they are not static. When it comes to static, it means that they are provided memory at static time, at compile time. But when it comes to class or say dynamic time, then they are having runtime memory allocation. What does it mean? It means that suppose I have made this code, okay, class and class, but when I will write the code and compile it, compiler won't be even be knowing that I have something called class, because this is dynamic. This comes into existence only when I create its object, not even when I just declare its object. So whenever I do home h, even it is not assigned any memory, but when I do create object h equal to new, it is assigned memory at runtime. Okay. We'll also have a look of its example, but before that, let's just clear some idea about class constructor. That is a new function. Class has a default built-in constructor new method. This is just a point to make out that what if I don't write any new method inside class? Here I have written some new method, but what if I haven't written? Then it will take a default one. Okay. But if I want to initialize something, then I will declare a explicit new function and I will give some initialization statement inside. Here I have class ABC, int a equal to 1. This is just kind of initialization I have done while declaring variable. Then I have taken function new. Inside that I have turned a equal to 2 and then end function end class. So as you can see that two initialization provided to variable a, one is while declaration and one is inside a constructor function. So who will win? The one that is inside new will win because this comes after my declaration initialization. So it means that whatever I have declared into new function, they will always work. So now let's have a look at this constructor inside our example going on. So here I'm taking one module A, it's n module in between. Now I'm taking home edge. So what I've done here, I have declared the object, not yet initialized. Okay. And now I'm making some procedure, say initial begin and inside that I'm saying if h equal to null means if it's not yet declared or not yet initialized, I will call h equal to new function. This is how it works that in a procedure I have called h equal to new. At this time it is being provided a memory. It is not compiled at static time. So this is a key concept of static versus dynamic. We'll have a look at the difference while we'll discuss class versus structure. So let's start with class versus structure. Now, if I look at the syntax of structure, my type def struct is nothing but a data type. I have named ABC. Inside, I have some property, say int A. Now I'm taking its instance, say ABC, ABC1. So my ABC1 is a variable whose type is ABC, which is nothing but a struct type. On the other side, when I'm working with class, what I said that class is again a data type, so it's similar to type def struct, right? So I have class ABC. Inside that I have int A. So this both almost seems similar. And then I have taken its instance ABC, ABC1. So it seems that both are similar. Then what are the differences between two? Okay. When we talk about struct, it is static. It means whenever this statement got executed, it was assigned memory. But when it comes to class, it's dynamic memory allocation. So when this statement was executed, it was not yet assigned the memory. When it will get memory assignment, whenever I will call ABC1 equal to new. After that statement only, it will get the memory. There are some more points to discuss about structure versus class. The first one is, and very important about class, it is the objects are created and destroyed dynamically. What does this mean? That when my compilation started or say where my simulation started, it is not necessary that my object was created, but whenever the new function was called, it was created. So it got created dynamically, as well as it will be destroyed dynamically. So at runtime, I may destroy this object. But like C++, it's not providing any delete function, but it follows Java's concept of automatic garbage collection. So whenever my object won't be used from long time, it will automatically destroy this object. Another difference between structure and class is structure can't contain method. We have worked with structure and it doesn't contain any function or task, but class can, which manipulates its own property. Another and major difference is that structure was being invented to implement the functionality of encapsulation. Means all data together. Here I can put any kind of data. But class is providing with encapsulation, it's also providing inheritance, polymorphism, etc. We'll have a look at this kind of key features of OOPS in next tutorial. Next topic is static property. Till now, whatever we have looked at is instance class property. What does it mean? That it doesn't exist before my object got created and after it will get destroyed. As we talked, class is dynamic and the lifetime of its variable is automatic. And scope, it is only accessible with instance of that class. But now we'll have a look at static property. So here I have an example. Same, I have a class A and class. In that, I have declared static int I. So I have put a static keyword before my integer declaration. Here, as int I is declared static into a dynamic class, memory assignment to the int I will be at static time, means at compilation time. Yeah, we can do that. Now, how can I access this static property using objects? So some points about static property are that I can access this property either using object or even without using object. How is that possible? Yeah, using object, I can say that after I have a1, then I will do like a1 dot I equal to 2, right? But the main point here is because this is assigned memory at static time, then all objects will share the same memory of this static property. What does it mean? That here I have taken instance of A as A1, A2, A3. All these three objects are sharing the same memory location of my int I. So suppose I have done a1 dot I equal to 2. Okay. Next I am reading like b equal to a2 dot I. What will be my b get assigned to? It will be the same one, 2, because a1 dot I was written to 2. Now b is equal to a2 dot I. It's again the same memory location, so its value 2 only. And then suppose I am doing a3 dot I equal to 4. So the same memory location got replaced by 4. So now again if I read this statement, then I will be having b equal to 4. Now the important feature is I can access static property even without using object. Because it's static, because it's assigned memory at compile time, there is no need that I create the object and then access it. So I can access it using class resolution operator. And what I have done here is then I'm using class resolution operator and then assign the value 2. As you can see, a scope resolution and a variable I which is equal to 2. Like this also I can directly access it. Lastly, today we'll look at static method. As we have seen that in static property we use static keyword. Here also we'll be using the same. We could access the static property with and without using object. For method also we can do the same. We will use the scope resolution operator for accessing that. And the point about static method is it can access only static property of the class. Yeah, this is common sense that if my property is not static, I can't use it into static method because the normal properties, instance property won't be assigned any memory at compile time. So I can't use them into static method. Okay. The example of static method here, suppose I have class A. Inside that, I will put a static keyword ahead my function f1. So here this function f1 now is static. There is a small difference and people get confused. So I have mentioned here the difference between static method and method with static lifetime. Okay, let's have a look at them. In first example, whatever we are doing right now, I have done that static function f1. In another example, I have put function static f2. This is the example that we have seen before while working with scope and lifetime. So what's the difference? This is the lifetime of method as a function within the class. So in this class, my lifetime of function f1 is static. In the another example, this shows the lifetime of arguments as well as the variables declared within the function. They are static. So make sure you don't mistake between these two. And that's it for the today's lecture. In the next lecture, we'll have a look at key concepts of OOPS. Thanks for watching, and you can look at the more videos at this website